This is Dan Rope and Gaia Paolini from the TIBCO data science team. Today we're going to show you some of our latest features for AutoML, including model explainability. So, what is AutoML? Well, if you think of machine learning as really a process with several steps for training a predictive model, AutoML is the automation and optimization of several of these steps. So what are some of the benefits? Well, for the data scientists, it can make the process more efficient, freeing up some of their time to try different approaches and different models. For a new data scientist, it enables them to get started faster and also get some guidance on some best practices for creating machine learning models. So what are some of the goals of this project? Well, first of all, we want to be transparent. We want to make it easy to see the steps that are taken during the machine learning process. Secondly, we want this to be scalable. So we built this on Team Studio, which is a highly scalable data science platform. And finally, understanding. We include model explainability so that we can better understanding of how a given model is making its predictions. So we have two demonstrations today. The first one is predicting fraud using structured data, and the second one predicts wine qualities, which includes some unstructured data. So let's go ahead and get started with the fraud example. So once I've joined up customer fraud and income data, then I just find the AutoML orchestrator operator from the palette and bring it to the canvas. I hook it up, and then I just choose the variable I want to predict, in this case, whether or not a transaction was fraudulent. When I run this, AutoML will find the best way to predict fraud. Once it completes, I can see all of the top models that it found and their relevant metrics. But this is not a black box. AutoML has generated visual workflows for me. These visual workflows prepare the data, they engineer new features, they find the best candidate predictors, and then they also train several machine learning models. Now these flows are also all editable. So for example, as a data scientist, I can edit it. So if I need a resampling operator to deal with target imbalance, I can just find it from the palette, bring it into the workflow, re-execute it, and then I can just see my updated results. Next, I'd like to understand how this model is making its predictions. For that, Guy is going to show us how to do model explainability in Spotfire.
Thank you. We will now open the Spotfire explainability file. By clicking on Generate Explanations, we have retrieved the data from the AutoML workflow. The top section shows general information. On the left, we have a bar chart with the predictors that were most important to the model. Credit score appears to be the most important predictor, followed by age and income. Let's explore credit score first by clicking on it. The layout changes. On the bottom left, we have a chart showing how other predictors correlate to credit score and also how important they are to the model. Age is both important and correlated. We now click on age and show that the layout changes again. We now have a chart with the values of both predictors. The colors reflect the model's predictions and their strengths, as showed in the buttons, which help select different areas of the chart. Points marked in gray are where the predictions are not clear-cut. In general, the model is doing better predicting non-fraudulent behavior. We can see that as a whole, credit score increases with age, and that predictions for fraudulent behavior tend to concentrate at the lower end of the credit score for each age bin. But there is also quite a bit of noise in this area. Some of this noise is due to lack of data, as we can see when we lower the acceptable volume limit, so all data volumes are acceptable. By clicking on Reset Views, or simply unmarking credit score, we are ready to start a new exploration.
Now let's take a look at how we would deploy and use this model. So AutoML also generates a scoring workflow for me. This has not only the model for making the predictions, but also all of the preparation and transformations required for that model, all automatically generated for me. When I'm ready, I can use that model inside of TIBCO's risk investigation app, where the model will reveal suspicious transactions, and investigators can then manage those transactions to resolution, and then we collect that data and feed it back in for future iterations of the model.
And now we will look at our second demo that predicts wine quality, making use of unstructured text data. This dataset contains information about wines, such as geography and main characteristics, and also reviews from wine experts. We want to predict a binary quality score. The orchestrator has new input parameters to handle text. It can be left up to the system to decide which variables contain text, or users can override it. In our case, we let the system decide, and the description column is recognized as text. Running the orchestrator produces an extra workflow, the text feature engineering. This has the task of encoding the text variable into a set of numbers or vectors using the word-to-vec neural net, so that the modeling algorithms can process it. The number of vectors to use is automatically selected by the system based on the structure of the description text. The rest of the workflow generation proceeds as normal, with the text vectors now fed into the model as new predictors. At the end of the run, we obtain a model with quite good accuracy and also good overall balance between outcomes. Let's now turn to the explainability in Spotfire. The page opens with a familiar bar chart of variable importance. As expected, price and alcoholic content are very relevant to the perception of a wine, but description features in third position, a sign that text did contribute to the overall prediction. The bars are colored by the data type. When we mark description, the first view that is displayed is slightly different. Here we see a selection of the words contained in the wine reviews. The words displayed are the ones that most influence the model, sized by their frequency of occurrence and colored by the predicted quality. The positions on the plot highlight the similarity or distance between concepts. In this case, the two groups appear well separated, another indication that they did play a positive role in the model accuracy. We can tune the display by increasing the word relevance cutoff so that the display is less crowded. We can see that many of the words match what we would expect, with beauty or superb denoted good quality, or simple and everyday used for more average wines. We also see that average wines may be associated with food that perceived as less exclusive, such as burgers, pizza, or pasta. There are other ways that make it easy to interact with the display, such as choosing different styles of plotting the words into 2 dimensions, hiding words that contain only numbers or choosing to display them, or hiding shorter words.
For more information about AutoML, please visit the community site where you can download AutoML and try it out for yourself.